So today we're going to be looking at arithmetic series. And now the whole point of using an arithmetic series, or what we're going to be studying, is the ability to move from a recursive formula to an explicit formula. Up until this point, if we say, hey, find the 10th or find the 100th terms of a pattern, we notice that the pattern adds, but we'd have to do that up till the 10th and up till the 100th time. So with this one, add 2, 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 all the way until we get to the term that we want. That not only invites error by the fact that you might miscount, it also is rather tedious. So let's see if we can't come up with a way to kind of jump ahead. So this is the arithmetic formula for an explicit term. And let's pull out, let's go with orange today. Our a to the n, what this is our term that we seek. So let's call this, just term that we seek. So whether it be the 10th, the 100th, actually let's zoom in as we do this. So the term that we seek, whether it be the 10th term, whether it be the 100th term, whether it be the 1000th term, this is the number in the sequence that we're trying to figure out what it is. The a to the 1, what this is this is the first term. So the first term in the series, whatever that beginning number is. If we look at d, d is going to be the difference. So what are we adding, what are we subtracting each time? And then n is the number that we are going out. So let's call it the spot / place in the sequence. Perfect. And so knowing these four things, we really only need to be able to plug in 2 in order to jump into the spot, the difference and the first term in the series. We'll be able to plug this in and that will spit out our answer. So without further ado, let us jump into number 1. So number 1, we've got a pattern 1, 3, 5. So we want to write a formula for this. Let's assume that we don't actually know what the difference is. So anytime we want to figure out what is being added, we just take any term and subtract the one before it. So I'll take 3 minus 1, 2. I'll take 5 minus 3, 2. So I know that this begets the difference is equal to 2. Awesome. Now we can fill out the formula. So I know that if a to the nth is equal to the first a plus that difference n minus 1 times, I can plug in this information. So the first term we know is going to be 1. So I'm going to go ahead and replace a to the 1 with just 1, because that is the first number in the pattern, the number 1. I know that the difference as of right now is 2, so I'm going to say we're adding 2, and we're going to do that n minus 1 times. Perfect. And now this is our formula. In essence, what this is saying is that we take the first number and we add the difference. So we'll add 2 one time, we'll add 2 a second time, and as n gets bigger, we keep working our way down the chain. That avoids us having to go through piece by piece by piece and add 2 several times. The reason why we subtract 1 from the n is on the first number. So on number 1, I don't want to add a difference just yet. So on the number 1, I want my n over here to cancel out my difference and give me 1, which is why we take the number, subtract 1, and we only have the difference that many times. For the third number in the sequence, I've added a difference twice, not 3 times. The third number, I've added the difference twice. For the 10th number, I'm adding it 9 times. For the 100th number, I'm adding it 99 times. That's why we always subtract 1. Now, if you wanted to, this is a formula. We don't necessarily need to simplify it, but if you wanted to go ahead and simplify it, let's do that in green. So the simplified formula would be to distribute this 2, and I would get a to the n equals 1 plus 2n minus 2, and then combine these two terms on the outer edges. So a to the n would be 2n minus 1. And this would be the fully simplified formula. Now, it doesn't really matter which one you use. You can use the original or you can use the end, depending on the context. So let's slide on over, and we're going to predict the 10th and the 100th terms. Now, I'm going to use the original formula, the one where we haven't simplified anything. You're welcome to use this, and you'll actually save a little bit of time, but I think this one's going to intuitively make more sense as we solve it. So let's go ahead and do this, but when I predict the 10th term, I'm saying that, let's go over, we said that n was in red. N is going to be equal to 10, and then later on, n is going to be equal to 100. That's what that is saying. We're going to use this and plug in an n of those two values. So I'm going to say a of 10, the 10th number, is going to be equal to 1 plus 2, 10 minus 1 times. I'm taking that number 1, and I'm adding a difference of 2 9 times. That'll bring me to the 10th spot. Over here, I would do the same thing. I would say to find the 100th term, I need to start out with a 1, and I'm going to add 2 99 more times in order to get to the 100th spot. Because if I added it 10 times, I would be at the 11th spot. I want to be at 10. If I added it 100 times, I'd be at the 101st spot. And then in essence, to figure this out, I just go ahead and I solve. So on the right-hand side, I'm going to distribute. 2 goes into 10, and 2 goes into -1. Actually, no, we're not going to distribute. We're going to simplify what's in the parentheses. Let's just follow order of operations. So 1 plus 2 times 9. So parentheses, exponents, multiplication, and division. So I'm going to multiply these two. 1 plus 18. And then I'm going to add 19. So a to the 10th is 19, which means the 10th term in that pattern is the number 19. To find the 100th term, I'm going to add 99 of these 2's. So that's 1 plus 2 times 99. That is 1 plus 198. This is 199. So my 100th term is 199. Perfect. Let's jump off into the next one. This one, instead of going up, we're going down. So let's assume, for the case, that we are unable to find the difference. I'm going to take the second number and subtract the first. So 351 minus 365 is going to give me, let's see, a negative 14. And then I'm going to do it again with the 337 minus 351. Let's see, the difference of that is, again, a negative 14, which means that my difference is negative 14. Okay? We can use this information to write our formula. We know our generic formula is a to the n, is that first term plus the number of differences n minus 1 times. So a to the n is my first number, which in this case is 365. And we are subtracting 14, so minus 14, n minus 1 times. This is our formula, and we're going to use that over here in just a moment. But if we wanted to simplify it, it's not too bad. I go ahead and I distribute the negative 14. Which means minus 14n, and that becomes a positive 14. And then my last set is to combine the 365 and the 14. So I have negative 14n. That's going to be plus 379. And that's the fully simplified version. Okay? So understanding that, what I want you to do is I want you to pause the video, find the 10th and the 100th term. So remember, think n equals 10 and n equals 100. Pause the video, unpause it when you're done, and see how well you did. Okay, so now that you've had a shot to try that out, let's take a look. So I'm going to say my 10th number is going to start out with 365, and I am going to subtract 14 10 minus 1 times. Or I'm going to subtract 14 9 additional times to go from the first term to the 10th term. So let's see what that looks like. 365 minus 14 times 9. Okay, 14 times 9, that's going to be, let's see, 90 plus 36. That is 126. 365 minus 126. Let's see, that'll be 359, 339, 239. So my 10th term is 239. Okay. And so for the 100th term, I'm going to do the same thing, but I'm going to subtract 14 99 additional times so that I can get to the 100th spot. A of 100 is 365 minus 14 times 100 minus 1. Oh, let's go ahead and get that. So with this one, we're going to go ahead and we're going to pop out a nice little calculator so that we can figure out some of this arithmetic that we're about to do, because I don't trust myself to do the larger numbers. Minus 14 times 99. And so here's where we get it. Actually, we could have done this because it's 140 minus 14, but why not? We've already got this. So 14 times 99 is 1,386. 365 minus 1,386. 365 minus the 1,386. And we get negative 1,021. So our 100th term is negative 1,021. That would be if we started with our original number 365 and we subtract 14, 99 additional times. We'll end up right there. Perfect. The last question, what would a graph look like of an arithmetic series? We should have at this point gone through the graphing videos. The length of the graph of an arithmetic series is always going to be a straight line. Linear. Remember, an arithmetic series is either a line going straight up, straight down, or flat. And there we go.